last part of chapter 4 is something called relative motion. So I want to introduce this idea of relative motion. And it has to do with coordinates and coordinate systems. So first of all, before we get to relative motion, let's talk about relative position. So I have an object right here, and I've got coordinates right here. And let's say this is 1, 2, 3, 1, 2, 3. So I would say it has an x value of 3 and a y value of, about 2.3 or 2.2 or whatever. Okay, whatever that comes out to be over here. Okay, all right, so, but let's say that I had coordinates over here. And in these coordinate positions over here, then this axis right here is x. So this is going to be x of the axis. And so that's going to be 3.3. And let's say it's got a y of 2.5 for the axis. Okay, now I could also give the position of this other object in these other coordinates. So I can call this x prime and y prime. And so, so the question is, what's x prime and y prime? Well, x prime is going to be equal to the x of the axis plus the x in the other coordinate system, okay? And y prime will be y of the axis plus the y. So in other words, that would be equal to 6.3, and this would be equal to 4.8. Okay, and so that is the idea of relative position. So I can give position relative to one axis or position relative to another axis. It doesn't change. It does not change where this thing really is located. It just changed what I call it. And we've done this already. We've already done this several times. We have an object right here, and you have a choice is where do you put your origin. You can put the origin there and say x naught is 0, or you can put the origin over here and say this is 0, and then that's going to be some x naught, not equal to 0. So we've been doing this relative position thing for some time. But now we want to talk about relative motion. Your book's definition of relative motion is a little bit hard. So what your book would do here is your book would say that you've got a moving coordinate system, and the coordinate system is moving, and we have an object here in the coordinate system. It has some kind of motion, okay? It has some motion relative to this coordinate system, and then that coordinate system has motion relative to another sort of thing. So, but it's the same sort of thing. If x, okay, if x prime equals x of your axes plus that x, then v prime, well, that's just the derivative of x prime. So v prime is going to be this. In other words, v prime is going to be the velocity of your axis plus the velocity in that axis. Okay, so we can actually make these vectors right here, and then that takes care of both the x, y, and the z parts of it. And so this is the idea of relative motion. And you go, oh my gosh, that's kind of complicated. Well, no, it's not. So imagine that you've got a highway here, okay, and let's say that you're driving down the road here, and you're driving at 65 miles per hour, and you look out the side of your side of the car, and you see an 18-wheeler going by, and it looks like it's going at 5 miles per hour past you. Well, how fast is it really going? Well, it's going 5 miles per hour relative to you, and you're going 65 miles per hour. So the actual speed of that thing relative to the road is going to be equal to 5 miles per hour relative to you, and you going 65 miles per hour relative to the road, so that's 70 miles per hour. Okay, well, of course, you already knew that. You were doing relative motion without realizing you were doing relative motion. Okay. Likewise, you can have, a car going this way at 65 miles per hour. You have another car going this way at 65 miles per hour, and one driver's not paying attention, they're messing with their phone or something, and they cross over, and we have a head-on collision. Well, how fast are the cars running into each other? Okay, so one's going 65 miles per hour this way, the other's going 65 miles per hour that way relative to the road. Well, relative to this car here, then it's going to be 65 miles per hour plus 65 miles per hour, or 130 miles per hour. Okay, so that's, of course, obviously why head-on collisions are absolutely devastating, because it's basically like hitting a brick wall, except going twice as fast as you're actually going. And so, again, this is the idea of relative motion and relative velocity. So now we'll just do a few examples with it.